Hello everyone and welcome to a revisiting of Module 4. I chose Module 4 primarily because it's something that almost, well, frankly, no one has completed yet. So I figured it's a good place to go back and revisit and see if we can, maybe I can add a little more color and help you guys get this done. So we'll go through the content in Module 4 briefly, and then we'll go through, spend a fair amount of time looking at the examples, so the deliverables and walking through that stuff. So Module 4 centers on indexing, grouping, and iterating. Most of what we talk about in this is around indexing. I'll probably try a little bit of ad lib around grouping as well. Grouping and aggregation is a key thing in data science and something that is very important for you to understand, as is indexing and iterating. Those are fundamental concepts that are essential to your success as a data scientist. So Module 4 talks about indexing, grouping, and iterating. The basic idea here is to utilize core programming concepts to desire basically what you want to, the desired outcome of analytical activities. There are some differences between the way that is done in grouping and iterating and filtering in Python and R. We'll spend a little bit of time talking about that. And then talking about techniques of doing the iterations and so in between. Your readings for Module 4 centers on Chapter 10, which deals around data aggregation and grouping operations in the Python for Data Analysis book. Learning R talks about Chapters 4 and 5, which deals with similar topics. So in grouping, the concept here is that you oftentimes do a group by in SQL. In R, you do a dplyr. Using pipes in Python, we typically use a split, apply, combine approach, although there is also the alternative of doing grouping essentially in pandas, and we'll talk about that for a moment. So moving on to pipes and redirection of outcome. So the basic idea is whenever you run a command, there's several things that can happen with the results of that command. One approach is you write it to something. So the example I'm using here is going out to a command prompt and using good old DOS, or what was DOS once long ago is now a command shell. And piping through various functions and commands is a common thing across multiple operating systems, including Windows obviously and Linux as well. So the basic idea here is that whenever you issue a command, you use that vertical pipe, the up and down bar, to say that what comes from out one should go to another command. So the more command is a command that lets you page through output a page at a time. Directory obviously lists the contents of a directory, so what you're doing here is saying take the contents of the directory and show it to me a page at a time. That kind of concept, and that's what we're trying to get at here, is the concept is important in data science as well. So how do we do that, this sort of concept in Python? Generally speaking, we use a group by sort of concept, and sometimes you'll actually use the command group by on a pandas data frame, but oftentimes you do this splitting, applying a function to each of the individual groups and then combine them back together as a result. That's the common pattern. And if you, there's some links down at the bottom around the pandas docs that talk about that kind of common pattern. To see it in motion, here we're taking a data set that's exported from the R, the mtcars data set. We're doing essentially a display of the data frame. Then we do some filtering, show me the vehicles that have more than one carburetor. And so that's going to get rid of probably anything that's really, really tiny. Then we're going to filter, group, and aggregate. So we're doing a group by cylinders, and then we're aggregating based upon miles per gallon, horsepower, and quarter second. We're taking the average of those, the mean, and producing a data frame that just contains that. Then we're using this columns.ravel functionality to essentially flatten that back out and combine together the two different headings of the columns into a single column name. And then we can go and use a similar approach using this split, apply, combine approach. So you just saw the pandas data frame approach using group by. Now we're doing something similar with split, apply, combine. So we basically will, in this case, we're going to do it on the iris. We're going to split things, and then we're going to group them by species, and then we're going to combine them back together. So I'll go ahead and switch over to a notebook so we can see this in real time. I think it's this one. So again, going through this same sort of example, we're basically going through importing various things. We're opening up the file and reading it in here. So the first part there is to figure out where is the file live at. Then once we get it, we can take a look at the data frame. One of the things you may notice is that I'm running some Jupyter extensions that let me show things like how long it took to run. That same set of extensions, which you can access once you've turned them on by going over to NB extensions, allows me to do things like make it pretty. So there's this formatting that basically turns the code into something that's a tad more attractive. So a useful hint, you may want to take a look at it, and to set that up, not terribly difficult. You do have to, though, do some installation of some libraries. So I'm looking for where I actually do that. Maybe I'll be a discussion for a later date, because I did actually write it out into a separate thing here, maybe. Now I'll have to track that down. Anyway, back to the topic at hand. So that's what you're seeing here is it took 33 milliseconds to run. Useful, and it also tells me when it ran, so I can then figure out if I've ran it recently or not. And so here you can see that was on 7/29, so not very recent. So this is the most recent at 8/12. So here we can basically filter those items that have more than one carb, and you can see it in here where the carb is 4 and the lowest is 2, and I just ordered it by the number of carbs. And we can also verify it by saying is the carb greater than 1, is a way of doing something similar, but we're doing that as something that's used to index it. And you can see here you've got an index that's coming back and a true false. And so what we're really doing here, whenever we do this empty cars bracket and then this expression, is per these indexes we're saying basically include this record or not in the resulting data frame. So that's how that's working under the covers. Whenever we deal with grouping, you do oftentimes the group by method along with the aggregate function, and you can do multiple types of aggregations across. It does, however, kind of stack them on top of each other in multiple layers of the groupings of the columns. You can flatten that out by doing this columns.ravel. It does appear that it's index.ravel is going to be going away at some point, so I'll probably need to figure out a cleaner way to do that whenever it actually does. A similar sort of approach is basically doing some filtering and then doing some aggregating based upon the number of cylinders. So we're doing a group by cylinders, and so we're basically showing the average, essentially the mean, of the various things when grouped by cylinder. So the average miles per gallon for a 4-cylinder is obviously the best, but the lowest horsepower on average, and also the poorest quarter mile, the number of seconds at a quarter of a mile. Where if you have a V8 or 8-cylinder, you're getting a lot less on average miles per gallon, have a lot more horsepower on average, but you're much faster. So there's kind of that trade-off. Here is doing the split, apply, combine. So we can basically take a look at the various, and all I did up here was grab the first and the first or 5 from in the kind of in the middle and 5 near the end, just to give myself a sampling of some records. Then we're doing a group by the species and calculating sums across everything that is numeric in nature, and it's grouped by the species. So the species becomes the index. And you've got the essentially the sum of the links, which may not be terribly useful. Probably better to do some sort of mean. Whenever you're doing these sort of calculations, minor things can make a difference, like the order in which you're doing stuff. By doing this first, you're essentially filtering out so that you're only calculating the sum of the thing that you care about. Here we're calculating the sum of all this stuff, and then we're picking out the one we want. So you're doing more work. And resulting in the same thing. So you're better off doing this. Not much of an issue in this particular case because we don't have a whole lot of data we're dealing with. But when you start dealing with larger data sets, it becomes much more of an issue. Here we're looking at a similar sort of thing, grouping by the number. And in this particular case, my claim that it's faster isn't necessarily being supported by, I guess it is slightly 3 milliseconds faster that time. So a minor difference, but You wouldn't notice that. I guess it's 10%, so it's not trivial. Maybe 5%. So anyway, again, this is basically the sort of things that you're doing when you do a group by. You can group by multiple things and basically do some summing those things up. So that's basically grouping in Python. Moving back to another sort of approach of doing grouping in Python using pipes is using dfply, or dfply is kind of a variation on R's ply approach. So moving back into a live demo, we can see it here of doing it within Panda, or doing it within Python using an approach that's very much inspired by what you do inside of R. So we start by making sure that it's installed. It's a library like lots of other libraries. Figure out where our files are, load those files, and we can see it's the same basic data we've been looking at. This is the way that it works as far as using a piping sort of approach. We're taking the data set that we just saw, so this data frame we loaded up here with the pandas read CSV. We've got that data frame. We're saying take that data frame, send it through this command, a select. So we're basically selecting 3 things of interest off of it, and then we're doing essentially filtering, so that we're saying where the number of carbs is equal to 1. So we're basically selecting cylinders, mile per gallon, and carb. That's where these 3 are here, and we're saying that the number of carbs has to be 1. So you can see the result. And this is a similar sort of architecture where if we're looking for those that are greater than 1, similar to what we did in the previous example. And then you can also do a thing where you do some group by and then run it through a summarize so that you can actually do the equivalent of an aggregate. This is accomplishing the same basic thing as this other example. It's just that it's doing so using this piping sort of approach, which may be easier for people to understand what you're doing. The code might be a little more concise. You always have to consider that part of your goal as a data scientist is not simply to get the right answer, but to do so in such a way that if somebody comes along later on, they can figure out what you did and why you did it, and it makes sense. You wouldn't want it to be such that they come along later and say, I can't figure out what this person did, right? Because they didn't include any documentation and they wrote code in such a cryptic way that you can't figure it out. These notebooks are a little light on documentation, but I'm providing the color commentary versus actual writing. This is code that would be delivered. So this is an example where we're chaining things together in a very explicit way of making sure that we're matching up our parentheses. And it's basically a similar sort of thing. We're basically saying, give me everything that's got carbs that are greater than 1. We're piping that through a group by the number of cylinders. Then we're calculating the average of miles per gallon for each one of those. And so it's a similar sort of thing. And also, you can save the result to a data frame. In this case, similar sort of thing. We're actually running the command, getting back a data frame that we're then using again to display. And you can see that it is a Pandas data frame. So it's a data frame like every other data frame. It's just that it's one that is being produced as a result of the piping operations. And then the last sort of thing is that a simple sort of read in the file, calculate the average mile per gallon per cylinder, summarization into a data frame. So a very common sort of practice that you might find yourself doing. So we'll go ahead and close this back and move over to the discussion again. Unless you're terribly interested, you probably don't want to pay too much attention to my machine learning example there. So back to our presentation. So this is an article that talks a bit about dplyr. Pretty cool stuff. Definitely worth figuring out because you do have this pipe concept. You can chain together commands kind of fairly similar in nature to what you might do in some functional programming perhaps. You have a select that is essentially the equivalent of a projection in SQL terms, where you decide what it is you want it to produce as the output of your your instructions. You have a filter where you mask it so that you're meeting some criteria for inclusion. Then you do a group by to enable some form of aggregation. So you're combining things together, very similar to the SQL group by. And then summarize is similar to the aggregate function that we've used on the group by at a data frames level, so that it does essentially the calculations of any kind of derivations based upon aggregates that you're producing along the way. So very, very cool stuff. When we talk about indexes, it's something that can be a little complicated. The index inside of a data frame, a pandas data frame, is generally speaking that first column, right? So most of the time, if you don't do something special, it's going to be pretty much a number starting at 0 running up to the number of rows in the data frame. It allows you to do things like recombine things back together. That's why that filtering based upon a condition is working, because you have that index underneath the covers working for you. So we'll go take a look at this notebook of should just probably click on it, but Python pandas. And computer's running a smidge slow. All right, so it's wanting a Python kernel, so we'll set to the Python 3 kernel. Apparently it was bound to a different kernel previously. So here we can go, and basically we're doing the typical import pandas as PD and numpy as NP. Almost every notebook or script you write will do that. Then we can create a data frame with a date index. So we're basically saying create something that ranges from the dates. This is a date range, so we're just doing essentially a list of dates from January 1st, 2000 through January 8th of 2000. And then we can basically use it as the index into our pandas data frame, and that's what this first column is. That's the index. That means that if we do something like combine it with another data frame that also has a date as the index, it'll just kind of magically work, right? Because the indexes are common and you can combine them. You can join obviously across different columns, but it is a way of being able to see that we're saying, give me back the first value up here, right? That's what we're doing here. And we're ignoring the index. We're just saying, give me the first one. You can also potentially select it by the index if that's what you're needing to do. So in this case, we're creating a data frame. It comes in with 0, 1, 2, 3. That's an automatically generated data frame index for you. And suppose you want it to be month as your index, you can do the df.setIndex, and it returns back a data frame that is set that way. But note here, we didn't save that, right? So this is a command that it's essentially a function that returns back something, and in particular what it returns back is a data frame. We then can combine that data frame or save that data frame with other stuff. Sometimes you'll see a lot of commands where you do this and then there's a dot something and a dot something and so on. All they're doing is taking advantage of the fact that this command returns a data frame unto itself. If we don't save it, it goes away. It's just there. It's being displayed on the screen and it disappeared. So if you want it to be saved, you've got to save it to a variable. So we would have new df equals that, and we would say new df. And those are doing the same thing. The difference is now, though, this exists here. So we can see that actually is being saved. It's not just being temporarily created and deleted. Also, you just saw me use another of the cool notebook extensions. These allow me to insert cells before and after the current cell, as opposed to the typical approach where you just can add it after. So kind of cool stuff, right? So moving on to set index, here you can set it to multiple columns. Again, though, note it's not being saved. So if I run this command again, it's going to be what it was before because we didn't actually say that. We'd have to save the output of this resulting command to another a variable if we wanted to persist it or use it. And this, we're basically setting it to where we've got an index of a certain range, 1, 2, 3, 4, and also a year. So we're combining those together in a way that they're combined together so that it's lined up in an incremental way plus a composite sort of index. Might not want to do that, but it is something that you can do. The reindex allows you to essentially set it kind of back to something else. So we start off with an example here. We're saying index is equal to 5 browsers, basically, some of which may not be real. But you have a response time and a status that's associated with each one of those. We can also potentially create a new, essentially, a vector here of new index that contains those values. To see it, we can do that, so you can see it is indeed what we just saved. And then we can say reindex using those values. The things that that were here that weren't previously inside of the data frame receive NaN as the value, so not a number, for any column where they're not being set, unless you supply a fill value command, which basically says this is what you used if there's not something, right? So it's a default value. And again, though, this isn't being saved until we assign it to some new variable. Here we're saying, well, okay, reindex it, this time put in zeros instead of not a numbers. The reason you do that is sometimes not a number is problematic when you're doing your processing. Sometimes you're better off having a number, even if it's 0, and so on. In the case of a status, it might be appropriate for it to be 0 or even not a number. Response time being 0 could throw things off depending upon what you're doing, but it is an example of setting the default value. You can also set it to be something else. So you can say it's missing versus 0. And this is where it gets really interesting because they're not necessarily strongly typed, right? So HTTP status is a column. Yes, these are numbers, these are not. So that's one of the things. You can have variant records inside of pandas, which is both useful and can be challenging. You can also reindex based upon the columns. So you can add new columns or remove columns depending upon what you want to do. And also you can use the axis style as the of where things are going, so you can kind of flip things if you really are so inclined. So in this case, we're sticking, though, with columns, and that's why we're here. So you can also do lots of interesting things with, again, indexes. So initially, we've got an index here off of the date and a value, some of which are not a number. And then we decide we want to expand that range. So we're saying, okay, before it was from 2010 January on. Then we say, no, we really care about 2019 or 2009 and in December. So it goes backward by a number of days. So you're increasing the size, but there's nothing there. But you do have the ability of saying that you want to backfill it. And what that'll do is take the first good value you have and propagate it backwards to those things you've added beforehand. So it is a way of essentially padding your data with something that's a reasonable estimate of what those values should be. Similar approach with this, but note some of these things actually should be a 0 in through here because it's and what we're doing here is we're adding the fill NA 0. So that's why we're going from NA for something that was inside the range, didn't get backfilled, and it's becoming 0 down here. These are getting the default values because of the chaining of things, right? Because we're taking our data frame, we're filling it, then we're doing a reindex. And this is where we're chaining together various commands. df2 returns essentially a data frame which has a fill NA evaluated on it, which then has the result of that has a reindex operation evaluated against it. Joining data frames is also something that we do a fair amount, and a lot of times you want to do it off of the key, but you sometimes also want to do it by a series of specific column names. So in this case, we're going off of _caller and _other. So we're combining those together based upon that. But sometimes you'll want to do it off of the natural key. So if you do that, then you can just join things together without having to supply any kind of additional commands, because in this case, we're having to say, well, basically this is kind of chaining things together and changing the names and setting the index temporarily inside of here. But down in here, we're basically setting it, saving them, and then joining them together. A little bit cleaner and perhaps a little easier for somebody to see what you're doing. And basically, some more generating of keys, and you can also specify what column to join on. So if it's in this other inside of data frame, we're basically saying join against this other data frame and use key as the column to join on. So with that, I'll go ahead and shift back over to make sure we have plenty of time to talk about R. So in R, we have this whole dplyr approach, right? And it uses a pipe, but it's a weird sort of pipe, right? Percent greater than percent, kind of a weird pipe, but that's what it is. It's the same thing as in a command prompt, an up and down line, or the greater than, and so on. So it's probably because that's what was available for overloading, but it is a little weird. So you have multiple approaches that you can use whenever you're piping in R. One is to use a nested approach where you have a series of commands that are nested inside of each other. And so you do an arrange, which is essentially sorting. Then you do a summarize. Then you do a group by. The innermost thing is kind of that group by. A filter where you're saying the where is inside of the most thing, and you're saying where carbs is greater than 0, and then you're wanting the cylinders. So you're grouping by cylinders, filtered by carbs, summarized and arranged, and you're calculating the miles per gallon, and then you're ordering it, the whole result of all that, by average mile per gallon in a descending order. Really ugly, right? That's why we don't want to do that. So to shift over into R, and you notice I'm running R inside of a data frame, or inside of a notebook. So this is what we just talked about, right? So we'll start off, we make sure that dplyr is installed and attached to it. So it is. Then we take a look at the mtcars, which is just kind of magically there for us. And so here we're basically piping mtcars through summarize, calculating the mean of displacement, mean of miles per gallon, and the number of records that exist inside of each one of those, and displaying it. This is a different approach, and this is what we just talked about, of not using a piped approach. You have to nest this stuff together. Really painful, probably really error prone as well, and something you probably really wouldn't want to do, because it is, you're probably going to regret doing it. And if you don't, the people that have to maintain it after you leave the company probably will. So another approach here is to use a series of variables, and that's what we talk about here, is multiple objects approach. Basic idea is that you take a command, you save the result of it to a variable, and then use that variable in the next command, so that you're basically chaining them together. So you derive A here, you say group by A using A, and then you say by cylinders, then you summarize the thing that you produced up here, B, calculating the average based upon miles per gallon. Then you order the results of the C that you just created there. The problem you have here is you're producing a whole lot of objects, and there's always the chance that you'll copy and paste the code and forget to change something. People do that all the time. And that's where the piped approach is kind of clean, in that it reads right to left, and you start off with the thing that you do first, which is taking the data frame, and then you're basically saying send that through filter, and which is what you're doing here. Then take that and group it based upon cylinders, then calculate the summary of miles per gallon, so the mean, and then you arrange it, so order it based upon the descending fashion of miles per gallon. So seeing that run, probably not a whole lot of difference in something this small as far as the time it takes to run, but in that particular case, it is probably a little faster, because you're not allocating and then eventually deallocating a fair amount of stuff. This one might actually, the nested option might actually be your highest performance, but it is exceedingly ugly. So all things equal, you would want to use a piped approach, because it's just from a maintenance perspective. That's one of the things you have to be considering as a software developer that happens to be being a data scientist, right? You're writing programs using a programming language with the intent of solving data science problems, but nonetheless, you want to think about what happens to the programs you write when you move on to the next job. So you want to keep that in mind, that you should be writing things in a way that is supportable and maintainable for somebody else to pick it up. And that's where the piped approach has a lot of value. dplyr is a similar sort of approach. It's basically and that's what we just talked about. Mutate allows you to add new variables and that are functions of existing variables. Select is what you would think. It's essentially projection in this SQL sense. Filtering filters things out. Summarize produces an aggregate, and then arrange is ordering the results. So pretty much what you would expect. We've already talked about that. So now we'll move into talking about deliverable 4. So your scenario here is you're building up your portfolio of stock price related stuff. And so you want to do some statistics between stocks side by side. So your instructions is to take the Google, Apple, Facebook, and Amazon stock prices, and that are presented to you in a singular row, right? And basically you're going to line them up based upon some stuff, right? So for your first submission, you take Python, you read in all 4 stocks, you read in all the file, and you separate those out, right? Stock prices into separate columns for each stock. So you're wanting to take determining the average stock price by considering open and closing, and by each stock. So that's where you're potentially going to be doing that split thing, right? And then combine. Then what you're going to want to do is do some covariance and correlation analysis between the 4 stocks. This will require reading and filtering each stock by stock name and assigning your frame data structure, not fame, so I need to put an R in there. And this is to be done in Python. Your submission should be your plain text file of the Python program, and so that I can evaluate it. So make sure you always include that source code. Your second submission, you're to take R and take a look at the stock prices per day from your favorite internet search engine. Yahoo makes this pretty easy, by the way, and determine the correlation and covariance between it and related stock prices for similar dates between Amazon, Facebook, and Apple. For the second submission, you're to use R. Use the input file from your first submission as your input. So you're basically going to use the same file that you did before, plus some additional stuff. In this case, it's the same sort of thing. You want your source code and plain text file and the associated output. The rubric, as always, shoot for that mastery, and the difference between mastery and non-mastery generally comes down to a mixture of data profiling and being comments. Obviously, that would figure into it too from a maintenance perspective, but also being able to handle and inspect the data and make sure that the data was loaded correctly, because that's the key thing. The difference between these as you read this is error checking the logic to significantly more error checking, right? So that's the key word. Significantly is the key piece versus yeah, there's some error checking versus you read it and there's no error checking, and the last one over here is you didn't even read it, right? So that's the key thing, is this significantly more error checking. The same thing in through here, significantly more error checking, and this is whenever you're doing the group by, and you can do those sort of error checking by either doing try excepts, that's a perfectly valid way, or making some assumptions about the shape of the data, the number of rows, columns, or whatever it might be. And the third rubric here is around using the R programming language and doing the part that we just talked about. To read data of Amazon, Apple, and Facebook into R includes significantly more error checking to determine if it was read. Again, that word significantly more, right? So making sure. And then in R, calculate the correlation and covariance of all the stocks, include significantly more statistical diagnostics such as min, max, standard deviation, median statistics. Covariance is going to be in there, and correlation as well, in addition to those others. And so that's pretty much the rubric for deliverable 4. As always, if you have any questions about the material I've talked about, let me know. That's what I'm here for. If you're having trouble with some concept, ping me. Shoot me an email, a message saying, hey, I don't quite understand what you mean by this. And I'll be perfectly glad to spend some time talking about it. Also, if there's anything I can do to help, if something's going on in your life and you need some help with something, let me know. That's what I'm here for. You're not in this alone. I'm here to make you successful as much as I possibly can. So as always, stay safe. If you have any questions, let me know, and we'll talk again on Monday. So please give me some hints of something you'd like me to talk about. Otherwise, I'll probably just pick up the next module after this one and go from there.